Welcome back. In this video, we are going to discuss about the binary heap. Okay, the binary heap actually it is also called as priority queue. Okay, it is used to support the following operations. If I want to insert element X, then return minimum value, return maximum value, and return or delete the minimum element. Okay, in this area this is most helpful one, and the applications it used in the register prims and event driven simulations of man coding heaps. Okay, first, we will discuss about the definition for this binary heap. Binary heap actually it follows the two properties, structure property and heap order property. Structure property almost it is a complete binary tree, but the heap order property is the minimum heap order. In this, the minimum value that should be placed in the root node. Okay, and the property minimum element is in root node, and heap with n elements has height of log 2n. Okay, just you can look this diagram. While you compare all the node values, the root node will be a minimum 1. Okay, and the next one is the binary implementation. The binary heap implementation, since it is a complete binary tree, so it will use an array concept for implementations. The parent node it will be placed or parent position is identified by using formula I by 2, and the left child it is identified 2i, right side means 2i plus 1. Okay, then the insertion operations. Before we are going to insert the element in a binary heap, first we have to ensure whether the extra space is available or not. If the extra place is available, then it will create a hole on over there, and before placing the value we have to compare and swap it. Okay, here what I'm going to insert, I want to insert the value 42. The available places, the next free slot is here only. Okay, so if I insert this value, if I am comparing all these three value, the 42 is minimum. That should be in the root node, right? So what we have to do, we have to swap the value. So the 42 will be come to the root node, the 53 it is attached in the right side. Okay, next again we have to compare. If I am comparing the value, a previous slide 45 42 is minimum, so here also we have to perform a swapping operation. Here the keyboard it is swapped. Again we have to compare these three values 6 14 and 42. The 6 is minimum, here the 42 is minimum, so no problem, it satisfied the property. While I am going to insert, first I have to increase the heap size by 1 so that it can store the new value. Next, if I insert the new element at the end of the heap, the newly inserted element may violate the heap order property, that is minimum value should be in the root node. Okay, so we have to compare, and if it is less than, then we have to do a percolate up. If I want to move the values in the upward direction, then I have to use the percolate up. If I have deleted the root element, then I have to use the percolate down. Okay. Then next I am going to insert 99. If it is max heap. Okay. In this tree I am going to insert just, so it is inserted over in here. Okay. Again we have to compare. If I compare, here the value is minimum maximum value is there, so maximum value should be in the root node, it is replaced. Then next another three values are compared, again it is moved to the root node, again this three values should be compared, again the 99 is greater, it is moved to the root node. Then next one is delete minimum. If I delete this 06 at the root node, just it will create a hole over there. First we have to compare next two values. If I compare this next two value, which one is minimum? 14. The 14 should be moved to the root node. The last values came here. Then next again we have to compare over here. 18 should be come to the root node. Next I have to compare here also. Which one is minimum? 53 is minimum, so it is ordered, so keep as such. So in this way we have to do a insertion and deletion operations in the binary heap. Thank you.